Hello and welcome to another GCSE Maths video. It has recently come to my attention that there is some confusion over the associative, commutative and distributive properties of addition and multiplication. To be honest, this is hardly surprising, as we're using some big complicated words to describe exceedingly simple concepts. So I wanted to take this opportunity to try and demystify the terms associative, commutative and distributive, let me put my tongue back in my mouth, distributive properties. Let's start with the commutative property. So the term commutative is just a fancy way of saying it doesn't matter which way round it goes. So for example, those who think it doesn't matter whether you add coffee to the water or the water to the coffee would say that the process is commutative, whereas those who say it does matter would say it is not commutative. And that's all the word commutative means. It means it doesn't matter which way round you do it. Now addition is commutative, and that means that a plus b is the same as b plus a. The commutative property of addition means it doesn't matter which way round you add the two numbers. For example, 2 plus 3 equals 5 is the same thing as 3 plus 2 equals 5. They both equal 5. This is a useful trick to remember if you have to add something difficult like 2 plus 104 in your head. You don't need to start with the 2 and count 104 from 2. You can just start with the 104 and count up by 2. Now addition is also associative, and that basically means that if we add a to the sum of b and c, that will be the same as taking the sum of a and b and adding that to c. Now this just follows logically from the commutative property of addition. Now multiplication can be thought of as a mathematical shorthand for saying we want to add a number to itself this many times. In fact, a common word for multiplication is times. That's where we get times table from. So instead of saying 2 plus 2 plus 2 plus 2, we can say 2 times 4. It should come as no surprise then that the commutative and associative properties extend over from addition to multiplication. But don't just take my word for it. 2 times 3 equals 6, and 3 times 2 also equals 6. And also 2 times the product of 3 and 4 is equal to 2 times 12, which is 24, and the product of 2 and 3 is 6, and when we multiply the 6 by the 4 we also get 24. When we combine multiplication and addition, we have to be careful what order we do the operations. So 2 plus 3 times 4 means add 2 to 4 lots of 3. This is because multiplication is short for do this so many times. The 3 is added to itself 4 times before being added to the 2. In other words, we are adding 2 to 12 to make 14. Now we can see that the commutative property still exists because 2 plus 3 times 4 is equal to 3 times 4 plus 2. It's also the same as 4 times 3 plus 2. And 2 plus 4 times 3. However, this relationship is not associative. So if we add 2 to the product of 3 and 4, this is not the same as taking the sum of 2 and 3 and multiplying the entire sum by 4. So 2 plus 3 times 4 is equal to 2 plus 12, which is 14. But that's not the same as 2 plus 3 equals 5, and 5 times 4 is 20. However, the relationship is called distributive. So 2 plus 3 times 4 is the same thing as 2 times 4 plus 3 times 4. This is because when we add first, then multiply, what we're effectively doing is multiplying the entire total. Okay then, so what does all that lot mean? Well, it's just a fancy pants way of saying if you've got two numbers, it doesn't matter which way round you add them, and it doesn't matter which way round you multiply them. And if you've got three numbers, it doesn't matter whether you add the first two to the third, or whether you add the first one to the second two. And that applies for both addition and multiplication. However, it does matter if you're combining addition and multiplication. It makes a difference whether you add first and then multiply, or whether you multiply first and then add. Okay, I hope you found that helpful. I'd like to wish you every success with your revision and your exams if you're taking them this year or whenever. And I look forward to seeing you in another video.